Let's look at some examples. I'm going to skip to B. So no negative exponents. This one, you just would simplify your 12 over 24 to 1/2. And then if you think about your factors of R, on top there are 6 of them. And then on bottom there are 8 of them. So R divided by itself is 1, 1, 1, so on and so forth. There are 2 leftover factors of R in the denominator once you've divided out all your common factors. So shortcut-wise, you could just subtract your exponents and go, hey, where were there more at? There were more s's in this case on top, so you'd have 2 factors of s on top. Now for a negative exponent. That's basically a 1 over k squared in your denominator, which means you'll end up multiplying by k squared over 1. But usually we kind of shortcut this and go, oh, well, it's a negative exponent in the denominator of a fraction. That's just going to flip it and move it up top. So you'll have your m to the third, k to the sixth times your k squared that moved on top, which will give you k to the eighth over m. And then you could divide out one factor of m and just have m squared, k to the eighth. On this one, there's a couple different ways you could do it. You could think of the whole expression as being to the negative second, and then make it 1 over that expression to the positive second, and then power raised to a power, you'd multiply your exponents together. Or you could go ahead and multiply the exponents inside by -2, and then individually think, well, that'll be 1 over x to the sixth and 1 over y to the eighth, and you'll get the same thing. Let's look at a couple more examples. So on this one, be really careful. You realize the negative exponent is only with the variable it's directly attached to. So the 4 is going to remain on top, just x squared will move to the denominator. And then with the quantity that is inside my parentheses, I'm just going to go ahead and multiply that exponent of 2 in there, which I can do because those are all single terms. And then again, just y is going to move to the denominator. Then I'll multiply straight across, which will give me 36, x squared, y squared, and I can divide out my x squareds to just get 36 over y squared. There's different ways you could have done that one, but that's the way I chose to do it. G looks like a mess, but let's see. I'm going to go ahead and take that whole quantity that's to the negative first to the denominator, which just leaves me with 2xy on top. And then my quantity from the top is now to the positive first. And just rewriting. So let's work on that 3x to the negative second in the denominator. I'm just going to multiply my exponent in, so 3 squared is 9, and that'd be x to the negative fourth. Then I'm going to move my x to the negative fourth to the top and multiply by x to the fourth, which if I multiply some things together, on bottom that's going to give me 27. And then I can make that x to the fifth on top and divide out some common factors. So that'll leave me with 3 factors of x on top since there were more factors on top to start with. And then y's divide out to 1. Let's look at this one. So on top, you have 2 terms being added, not a single term where everything's multiplied. That x to the negative first is part of the group that's being added to 2y. So when I rewrite this, I'm going to have in my numerator of my fraction 1 over x plus 2y. And then the denominator is still 5x. You can't go ripping apart that quantity that's being added on top. Now this is essentially a complex fraction, so I'm going to go ahead and work on the top by getting a common denominator, which means I need to multiply by x over x. And then I can rewrite the top as a single fraction, 1 plus 2xy all over x. And then remember my bottom is 5x, so I want to multiply by the reciprocal. So if I take and multiply by my reciprocal, since I'm dividing my 5x, I'll just have to multiply and divide out my common factor of x right now is easiest. So you'll just have 5 times 1 plus 2xy, or you could multiply it in and make it 5 plus 10 times xy. It doesn't matter. We're going to go back and talk about greatest common factor again for a second. So if you have that top expression in blue, when you're looking at common factors, you'd find that they share two factors of x. It's basically your smaller exponent on your shared variable. So you could factor out x squared, and what you're really doing, if you think about it, is like taking away two factors of x. So like on your exponents, you're subtracting 2, which leaves you with 3x to the second, and then you took out all factors of x in your second term. X to the 0 power is just 1 if you think about it. 5 times 1 is 5. If you think about one with negative exponents, x to the negative 4th is a smaller exponent than the negative second power. So my common factor is going to be the one with the smallest exponent. So I'm going to factor that out, and that's going to leave me with, well, you could think, okay, yeah, I took away all x to the negative 4th. I'll just go ahead and write it. Like I'm subtracting my negative 4 from my exponent. I'm subtracting negative 4 from my negative second exponent that I had. So that'll leave me with x to the negative 4th on the outside times 3 plus, and then 5 times you have x to the negative 2 minus 4, so that's negative 2 plus 4 gives you x squared. And you could check by multiplying it back together and seeing that it equals the original.